then up into the CTO of Elsevier. Our role is trying to understand and map how emerging technologies are going to impact Elsevier's business models a few years out. We're a mix of researchers and some pretty darn experienced software developers. And we do two main modes of work. We do targeted research. We're reviewing things in the computer science literature, usually related to AI, and applying it to medical and scientific domains. That's stuff that's a couple years, 3, maybe on Elsevier's business models. We also do accelerated development in partnership with our product groups. That's stuff that's a little closer horizon. It's maybe a year out. It's stuff that's on the roadmap, but it's just out of reach. And sometimes by coming in and helping with the technical side of that, we can speed that up. There's 10 of us in Elsevier Labs. There's only 9 pictures on this page because I don't have a photo of our most recent member, but there's bios on that URL there. You'll get these slides. That'll give you a feel for kind of the various pieces of expertise we have in the group. In terms of the research we do, it's kind of all over the board, but like I said, it's typically in applying machine learning and AI to the field of science. So we do image classification work and image analysis, do a lot of natural language processing and neural language models work. We're getting deeper into deep learning, done work with tables, with bibliometrics and citation graph analysis. Then we do a lot of stuff around building knowledge graphs and applying test question to our content. And I think that has significant strategic implications, not just for Geofacets, but for all of our products. Like I said, we do some product feature development. I'm not a software engineer, so I do POCs that I then hand off to technical groups that make things actually work. My code is guaranteed to break at some point, but a couple of projects that I'll show today, from a colleague and one of mine, are in production already. And I think it's especially interesting in the context of this third-party data integration stuff that you're all talking about. I think that our natural language processing expertise can really help you as customers index and analyze your data and get it meaningfully into that Geofacets interface alongside of our articles. And we've done that work in other industries, as Samir mentioned earlier, particularly with pharma and with health sciences. So the sort of next third of my presentation is about a couple of labs and Geofacets engagements we've done over the past few years. I'm going to touch on very briefly one slide on this image classification project. I'm going to go into a little more depth on some text-based geolocation work, and I'm going to talk a bit about tables interpretation before I get on to sort of my current research. On the image classification, this is work from my colleague Sujit Pal that was productized a couple of years back. It's pretty straightforward, but if you're familiar with the Geofacets UI, you know that content type facet you get on the side that tells you what kind of image an image is. Well, that's based on a machine learning classifier that Sujit built and then the Geofacets technology team productized. So it will classify these images as to whether they're a map or a table or a plot or a stratigraphic column or whatever. And that's work that we did in labs and then rolled out with the technology team. Similarly, in the one that I'm more familiar with, because I did a lot of the work, we built a custom geolocation index a couple years ago. So text-based geolocation, you might think is a solved problem, right? You go to the internet, you type in Paris, France, Google Maps will show you exactly where Paris, France is on a map. There's a lot of systems that do that. The challenge here, though, is that those systems are optimized for geopolitical entities and maybe corporations too, right? You can look up where the nearest Walgreens is to you if you're here in New York City. But when you start looking at geological content, and I have here the Wikipedia page listing Cratons and Shields, Google Maps and these other tools don't know what to do with this kind of thing. So an example that I like to look at, the Fennoscandian Shield, right? Look that up in GeoNames. It doesn't know about it. A defunct system that I used to work with called Who's On First was not familiar with it. Google Maps doesn't know anything about it. The Getty's Thesaurus of Geographic Names doesn't know about it. OpenStreetMaps doesn't know about it. The Library of Congress, interestingly enough, knows about it. It's a variant of Baltic Shield for them, but it doesn't give you any geographic coordinates. It doesn't tell you where this thing is. Similarly, something like the San Andreas Fault, pretty common knowledge where this thing is, but if you look it up in GeoNames, you'll notice it gives you a Latin long for it, but it's a Latin long of a point. We all know that the San Andreas Fault is not that point off the shoreline highway, right? So this is a problem for trying to do text-based analysis of this geological content. So we had a research proposal. Can we roll our own? Building it based off of Geofacets data, because we know that we have these geo-referenced maps that have these areas of interest, and they have article metadata and captions and titles associated with them, right? So Geofacets, if you search for Fennoscandian Shield, you'll see that it does, in fact, give you a lot of hits right where you would expect it to, around the Baltic Sea and in the Nordic countries. And the reason for that is because we have all these maps, right, where we know where that map is, and then the caption of the map mentions this thing. So essentially what we did is we took all those maps and we found an average location for all of these geologically specific named entities that we could find. And there's some noise in there too that you'll see a little bit later in my talk. But for the most part, for things like the San Andreas Fault, we're able to get a pretty good estimate of roughly where across all of the stuff we have, where it thinks that resource, that thing is. Similarly, Fennoscandian Shield, it gives a pretty good, this is a heat map of sort of the average density of map locations associated with that term across the whole Geofacets database. And we've built this out for hundreds of thousands of these geoterms. I'm not going to go into the technical details on how this was built. I've given talks on that before. If people are interested, maybe follow up after the call. We might be able to talk about it at some point, but I will talk briefly about work we've now done to operationalize it. Because I handed this off and then worked very closely with the Geofacets tech team to figure out how to apply this at a document level. And it raises some interesting questions, right? What is the relationship between a document level mention and document level aboutness? Particularly when you have long documents. If you mention a geographic location in passing, but it's not what the document is about, you don't necessarily want to put that document on a map at that place. So we look at a couple different heuristics. How often something is mentioned in the document, and then also the various entities mentioned in that document, how do they cluster together geographically? How do they group? So we built a system that's going to detect and count all of the location mentions in either born digital, naturally digital materials, or OCR documents. And then it uses our local index plus OpenStreetMaps for those geopolitical things I was talking about before, and does some filtering of those based on things like term frequency and inverse document frequency, and based on a proprietary algorithm for, like I said, clustering those geospatial entities, figuring out where a lot of the things mentioned in a document group together in order to try to put these non-map documents on the same UI as everything else, right? So now we're in a position where we can take spreadsheets and PowerPoint presentations, PDFs, Word documents, even emails, and know approximately where on Earth they're speaking about, and then put them into the same Geofacets UI that you would put your more traditional map-based content. I mean, that's pretty powerful stuff. I want to talk now about another project from, it's a couple years back. It was put on hold for a while, but I think we're going to ramp it up again soon, around extracting information from tables. Now, I was working on this for a couple of different applications, but through some conversations with Gilad and John at the time, I started looking at it in a Geofacets content too. So I took a few 100,000 tables that are in Science Direct and are also in Geofacets, and I wanted to look for something of meaning to geologists. So we settled on total organic content as something that would be worth digging up. And we wanted to look at where these entries on this table sit on Earth, right? And so you're seeing here, we're working with ones that have latitudes and longitudes, but you could just as easily imagine there's a column here that just says location, and it has some free text that we then use that previous system I just described to geolocate, get a centroid for it, and then do the same thing that I'm about to show you. We chose latitude and longitude because if you look at the variance here, it's interesting, right? You have sometimes the degrees and minutes split into separate columns. Sometimes they're together in a column. You have decimal degrees. Sometimes there's a lot of variation, and we wanted to look at how to normalize that. So the first thing we do is look at variability of the headers, right? So this is again, thousands of tables from Geofacets, and looking at the different ways that we can find latitude represented. And you'll see that most of them are straightforward, but there is some variation, and it comes in a long tail form. There's a very long tail, but if you normalize the stuff near the head, you get a lot of that content. And if you look at that long tail, for example, I love that all the way at the right, there's a latitude west. Some author somewhere made a mistake in entering their data because we don't have east and west latitudes so far as I know. But anyway, this is interesting stuff. Do the same thing with organic content, right? Looking for the different ways that's represented in these headers. And in addition to the header variability, we looked at some fingerprinting of the content itself, right? So what is it? What is the pattern of the underlying data? You might have a number, or a number followed by a degree symbol, then another number, or with that minute tick, or with this notion of north or south, right? And we looked at the distribution there, and we started building normalization routines for the most commonly occurring examples. Again, I'm not going to get into this in too much depth, and this is only a piece of that normalization, but you'll see if you know software, a couple of things happening in here. One of them is we're taking those minutes and seconds and we're converting them to decimal degrees. Another is we're looking for flags that indicate that something is a south latitude, and we're flipping it to a negative value so that we can have a data set that is pretty homogeneous, so that we can then merge and visualize that data. So for this experiment, I took 20 articles that mentioned latitudes and longitudes, a TOC, and some notion of a depth. 21 tables from those articles, about 850 data points. And we can take them all, normalize them, and plot them on a map, where every one of these points is actually a cell from one of those 20 tables. And we have the metadata about where it came from. We have a link directly to that table in Science Direct, and we have the TOC and depth value for each of them. Now, since those TOC values are also normalized in their percentages, we could also render this as a heat map if we wanted to visualize it in order to try to see where the higher versus lower values for that were. Now, I'm right about where I want to be at this point in the presentation. I'm going about 14 minutes in, and I'm going into the sort of the last segment, which is on our current R&D. I'm going to talk a bit about units of measurement and annotations. And what I mean by annotations, I guess, is anything, think about annotating or marking up a article you're reading, right? You're imposing knowledge from your worldview and from your systems of knowledge onto the material you're reading to say that, like, oh, this thing I underlined is an example of X, right? And we have built a system called Content Annotation Toolkit for taking those and being able to query them and analyze them and sort through them. We've got an open source software package that my colleague Darren built called Annotation Query that does just that. Now you can think about anything as an annotation, right? On the left, we have personal names and corporate names and song and television and movie show titles. On the right, we have genes and proteins and cells. The stuff that I was showing with geological place names can be rendered as annotations. And in fact, we implement it that way in a lot of the querying tools that I've built on top of it. And I think of these as sort of building blocks for text analytics, right? In addition to those entities, we have annotations about the markup of the XML. So we can look at section headers and paragraphs and captions. We have annotations related to parts of speech, sentence breaks, paragraph breaks, noun phrases, whole dependency trees and constituency parse trees, if you remember diagramming sentences when you were a kid. And we're able to query across all of them. So one of the first things I was asked to do when I joined Elsevier 4 years ago was to learn the system that we've built for doing all of this and then implement a set of annotations for you. The units and measurements piece, pretty straightforward, right? You look for numerical patterns, a number with a tolerance or a range of numbers, followed by some kind of known unit, SI unit, right? A degree Celsius, micromoles, whatever. And you can imagine these things being useful in almost any scientific domain, right? You've got examples related to neuroelectric properties, related to the compressive strength of things for material sciences, for drug dosages. So when I started prepping this presentation, I was like, all right, what does this look like for some Elsevier content? So I took 1,000 Geofacets articles. And the first thing I do when I'm doing this kind of analysis is I look for any kind of a noun token after a cardinal number, which are often my units. And I get a distribution of those across the text. So across those 1,000 Elsevier Geofacets articles, I find these units. And right off the bat, I'm finding ones that I didn't configure before. I haven't been working with giga-annum and kilo-annum, right? Because I don't work with that kind of material very often. I hadn't worked with per milli, that weird 1/1000th version of a percent. So I added those to my config. And then the kinds of things we can do with that is I can grab, for example, the percentages, and I can search that subset of articles for paragraphs that contain a percentage and some notion of TOC. And I can find thousands of them, or actually no, hundreds of them that bubble up. I could also take those geological entities I was showing you before. Now I mentioned there's some noise in there. I mistake some things for proper nouns when they're not. So the formation is clearly not a specific location, but it's in that system. We're working on cleaning some of that up. But you see a lot of the things that do bubble up here are specific locations. So I grabbed the fourth one there. 2,000 occurrences of the Ordos Basin in these 1,000 articles. I can add that to that last query I showed you, and I can say, okay, show me paragraphs that mention TOCs, have a percent value, and mention the Ordos Basin. And it retrieves 2 paragraphs from our data. And I can very quickly kind of sort through and slice up our content in these ways, and potentially your content too, in order to better understand from the unstructured text, what kinds of things are being talked about and what kinds of quantities you're finding in there. The last thing I wanted to look at was a correlation matrix, and I did this at the paragraph level. So this is the most commonly occurring combinations of a term from that geolocation dictionary and a unit of measurement at the paragraph level across those 1,000 documents. And what you're seeing here kind of makes sense, right? You're seeing lengths of rivers, you're seeing depths of oceans and trenches. But you can then start sorting through this in different ways. And you could say, for example, look at that Jumana River in kilometers and the 187 paragraphs that occur there and grab the numerical values associated with those paragraphs and average them to get presumably close to an average length of the Jumana River across a whole bunch of different pieces of content. So the last thing I'll show you is I'm playing with this in the context right there of very sort of symbolic AI, right? We're building systems based on things that we know to look for and matching patterns and analyzing stuff. But we're also doing a lot of work on using neural networks for the same thing. And on a whim a while back, I was taking a neural network model trained in question answering on this thing called the Stanford questioning answering data set. And I started throwing some random paragraphs at it, including this one. I was amazed at what I found because I asked this question about total organic content and the model could work out that one, my less than 2% was the same thing as the one with the symbols in the text. And it could do the co-reference to work out what I was referring to with total organic content and how to map it to that TOC. Now, this was a fluke. This was this didn't scale. Like, it didn't happen over and over again. It just happened with this document and a few others. But it got to me thinking that if we had a data set to actually train these things on, we might be able to train neural models to do this kind of stuff for us, to interpret these measurements. And so I built one. We're building a training data set, and we got accepted into this thing called SemiVal, which is it's computational linguistics workshop series that does contests. And the great thing about this is we're putting this data set out there about interpreting units of measurement, and we have 67 teams of NLP experts around the world already signed up to engage in this. So this just started this month, and it's going to run till early next year. That's my main work right now, and that's the end of my presentation.